What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you exactly what an IP address is in case you have no idea. So let's get into it. In the digital age, the term IP address is frequently mentioned, but not everybody fully understands what it means or why it is crucial. An IP address displays a fundamental role in enabling communication and connectivity in the vast landscape of the internet. In this video, we're going to talk about the concept of IP addresses, explaining what they are, how they work, their structure, types, and significance in modern networking. All right, so first things first, what is an IP address? So an IP address, this is a unique numerical identifier assigned to each device connected to a network that uses the internet protocol for communication. It serves two primary functions: identifying the host or network interface and providing the location of the host in the network. And this enables devices to communicate with each other over the internet or local networks. And here are some of the key characteristics of IP addresses. First one is its uniqueness. So each IP address is unique within its network, ensuring that data sent over the network reaches the correct destination. Then there's logical addressing. So unlike MAC addresses, which are hardware-based, IP addresses are logical addresses assigned by the software. And then there's a hierarchical structure. So IP addresses are structured hierarchically, making it easier to route data across large networks, such as the internet. All right, so let's go ahead and talk about the structure of an IP address. So IP addresses come in two versions. You have IP version 4 and IP version 6. And each version has a different structure and format. When it comes to IP version 4 addresses, these are the most commonly used versions of IP addresses. An IP version 4 address, this is a 32-bit number, typically represented in decimal format as 4 octets separated by periods. And each octet is an 8-bit number ranging from the number 0 to 255. So for example, an IP version 4 address might look like 192.168.1.1. And then we have IP version 6, and this was developed to address the limitations of IP version 4, particularly the exhaustion of available IP version 4 addresses. And an IP version 6 address is a 128-bit number represented in hexadecimal format as 8 groups of 4 hexadecimal digits separated by colons. So for example, an IP version 6 address might look like this long number on your screen right here. Now, to simplify notation, IP version 6 addresses, they can be abbreviated by omitting leading zeros and using double colons to represent consecutive groups of zeros. So for example, this long IP version 6 address right here on your screen, if we were to take out all of the zeros, especially these zeros right here, you'll see that they have been substituted with double colons. And then you see the leading zeros in front of this group right here and the leading zero in front of this group. We've removed them from the overall address to shorten it out to look like this right here. All right, so let's move on and talk about exactly how IP addresses work. So IP addresses, they operate at the network layer or layer 3 of the OSI model, and they are used to identify devices on the network and to facilitate the routing of data packets between these devices. So here's how IP addresses work in practice. The first component is the address assignment. So IP addresses, they can be assigned manually, which are known as static IP addresses, or dynamically, which are known as dynamic IPs. And static IPs, they are fixed and do not change, while dynamic IPs are assigned by a DHCP server and they can change over time. And then we have what is called data packet creation. So when a device wants to send data over a network, it creates data packets that include the source and destination IP addresses. And the source IP address identifies the sender, while the destination IP address identifies the recipient. And then we have the routing process. So routers, they use IP addresses to determine the best path for forwarding data packets from the source to the destination. And routers maintain routing tables that contain information about available network paths and their associated IP address ranges. Then we have data transmission. So data packets, they are transmitted over the network from router to router until they reach the destination device. And each router along the path examines the destination IP address and forwards the packet accordingly. And then we have data reception. So the destination device receives the data packet, checks the destination IP address, and processes the data if the address matches its own. All right, so let's go ahead and talk about the types of IP addresses that are out there. So IP addresses can be classified into different types based on their scope, purpose, and assignment method. And here are some common types of IP addresses. The first is called a public IP address, and these are assigned to devices that connect to the internet. They are unique and globally routable, meaning they can be accessed from any device on the internet. And public IP addresses are assigned by ISPs or internet service providers, and they are registered with the IANA or the Internet Assigned Numbers Authority. And then we have what are called private IP addresses. And these are used within private networks, such as homes or businesses. They are not routable on the internet, and they are intended for internal use only. And private IP address ranges are defined by the IETF, or the Internet Engineering Task Force. And they include all of these ranges right here, starting with 10, 172, and 192. So basically, if you have a computer in your network right now, which you more than likely do, your IP address more than likely starts with one of these numbers right here. And then your devices, they're connecting to your home router, and they're reaching out and watching this current YouTube video, or your router, this has a public IP address. And all of your devices within your little local area network, they have private IP addresses. So basically what I'm saying is, you're on your phone listening to me on this YouTube video right now, and this is your IP address. Well, the YouTube server that you're connecting to, it has no clue what the IP address is to your phone. The YouTube server is connecting to your router because it can see that IP address. And then once the information is exchanged back and forth between the YouTube server and your router then sends that information down to each unique device based on its IP address. We also have static IP addresses. So like I stated earlier, static IPs, they are manually assigned to devices, and they do not change over time. They are typically used for servers, network devices, and other critical infrastructure that requires a consistent address. We have dynamic IPs, and they are assigned by a DHCP server, and they can change each time a device connects to the network. And dynamic addresses are commonly used for end user devices such as computers, smartphones, and tablets. There are also loopback IP addresses, and these are used to test network interfaces and software within a device. And the most common loopback address is 127.0.0.1 for IP version 4 and ::1 for IP version 6. And then we have what are called multicast IP addresses, and these are used to send data to multiple devices simultaneously. They are commonly used for streaming media and online gaming. And IP version 4 multicast addresses, they begin with 224.0.0.0 all the way to 239.255.255.255. And then we have what is called a broadcast IP address. And these are used to send data to all devices within a network segment. And the IP version 4 broadcast address is 255.255.255.255. All right, so let's move on and talk about the importance of IP addresses. So IP addresses, they are fundamental to the functioning of the internet and network communication. And here are some reasons why IP addresses are essential. First is unique identification. So IP addresses, they provide a unique identifier for each device on the network, ensuring that data is correctly routed and delivered to the intended recipient. Then there's efficient data routing. So by using IP addresses, routers can efficiently determine the best path for forwarding data packets, optimizing network performance and reducing congestion. Then there's network management. So IP addresses, they facilitate network management by allowing administrators to assign, track, and control devices on the network. Then there's access control. So IP addresses are used in various security mechanisms, such as firewalls and access control lists, to restrict network access to authorized devices. And then there's troubleshooting. So network admins, they use IP addresses to diagnose and resolve network issues, monitor traffic, and identify potential security threats. All right, so let's go over the differences between IP version 4 and IP version 6. So while IP version 4 has been the dominant IP address scheme for decades, the exhaustion of available IP version 4 addresses has led to the adoption of IP version 6. And here are some key differences between version 4 and version 6. So when it comes to IP version 4, the address length is 32 bits. Its address format is in dotted decimal format, which has 4 octets separated by periods. Its address space is approximately 4.3 billion unique addresses long. When it comes to its header complexity, it's simpler with fewer fields. It has support for network address translation, or NAT, which is commonly used to limit address space. And then when it comes to security, it is optional, and it relies on external protocols like IPsec. When it comes to IP version 6, its address length is 128 bits. In its address format, it is in hexadecimal notation, comprised of 8 groups of 4 digits separated by colons. Its address space is virtually unlimited because there's approximately 340 undecillion unique addresses. So just think of 340 billion addresses. When it comes to its header complexity, it's more complex with additional fields for improved functionality. It does have support for network address translation, although it's not needed due to the abundant address space. And it has built-in security for IPsec, providing enhanced security features. Now let's move on and talk about the transition from IP version 4 to IP version 6. So the transition from IP version 4 to IP version 6 is necessary to accommodate the growing number of devices that are connected to the internet. However, the transition process poses several challenges. The first is compatibility. So IP version 4 and IP version 6 are not directly compatible, requiring mechanisms such as dual stack tunneling and translation to enable communication between the two protocols. And dual stack, this allows devices to run both IP version 4 and version 6 simultaneously. Tunneling, this encapsulates IP version 6 packets within IP version 4 packets. And translation, this converts packets between IP version 4 and IP version 6. Then we have infrastructure upgrades. So network infrastructure, including routers, switches, and software, they must be upgraded or configured to support IP version 6. This requires investment in new hardware and software, as well as training for network administrators. Then there's application compatibility. So applications and services, they need to be updated to support IP version 6. And this includes ensuring that software can handle IP version 6 addresses, making necessary changes to network configurations and protocols. And then there's address management. So transitioning to IP version 6, this involves rethinking address management practices. While IP version 6 simplifies address allocation due to its vast address space, it also introduces new considerations for subnetting and hierarchical addressing. Now, despite these challenges, the transition to IP version 6 is essential for the continued growth and scalability of the internet. And organizations and service providers are gradually adopting IP version 6, and many new devices and networks are being deployed with native IP version 6 support. All right, so let's go ahead and talk about how you can find your IP address if you have no idea how to do this. So finding your IP address, this can vary depending upon the device and operating system that you are using. So here are some common methods for locating your IP address. So when it comes to Windows, you want to use the command prompt. So you want to open the command prompt by pressing the Windows key plus the letter R, and then type the letter CMD for command, and then press enter. After you do that, you want to type ipconfig and then hit enter, and your IP address will be listed under the network adapter that you are using. If you're using your network settings, you want to go to settings and then go to network and internet. You want to select Wi-Fi or Ethernet, depending upon your connection type. And then you want to click on the network you are connected to, and your IP address will be displayed under the network details. If you're on a Mac, you want to use your system preferences. So you want to go to your system preferences and then hit network. Then you want to select the network connection that you're using. And then your IP address will be displayed in the connection details. Or you can use Mac's terminal, which is the same thing as the command line interface in Windows. So you can open the terminal by going to applications, selecting utilities, and then selecting terminal. Then you want to type ifconfig and then press enter. And your IP address will be listed under the network interface that you are using. If you're on a Linux device, you want to use terminal. So open that up, type ifconfig, or you can type the command IP space ADDR space show and then hit enter. And your IP address will be listed under the network interface that you were using. If you're on a mobile device like Android, you can go to settings, network and internet connections, select Wi-Fi, and tap on the network you are connected to. And your IP address will be displayed. If you're on iOS, just simply go to settings and Wi-Fi, tap on the information icon next to the network you're connected to, and your IP address will be displayed in the network details. All right, so let's go ahead and talk about IP address security and privacy. So IP addresses play a crucial role in network communication, but they also have implications for security and privacy. So here are some considerations. The first is IP address tracking. So IP addresses can be used to track online activities and identify the geographic location of users. Websites, advertisers, and cyber criminals, they may use IP addresses to gather information about users. Then we have what's called IP address spoofing. So attackers attackers, they can forge IP addresses to hide their identity or impersonate other devices. In IP spoofing, this is commonly used in attacks such as denial of service and man-in-the-middle attacks. Then you have what is called a DDoS attack, and this stands for a distributed denial of service. And this is an attack that involves overwhelming a target device or network with a flood of traffic from multiple services, and attackers that use IP addresses to direct the traffic to the target. But there are some mitigation strategies. The first is a VPN or a virtual private network. So using a VPN, this can help protect your IP address and online activities by encrypting your internet connection and routing it through a secure server. Then there's firewalls. And firewalls, they can help prevent unauthorized access to your network and devices by filtering incoming and outgoing traffic based on IP addresses and other criteria. Then you have IP address filtering. So if you implement IP address filtering, you can use it to restrict access to your network or services to trusted IP addresses. And then you also want to do some regular monitoring. So you want to regularly monitor your network for unusual activity and potential security threats. And you can use intrusion detection and prevention systems to identify and respond to attacks. So to wrap all this up, IP addresses, they are a fundamental aspect of modern networking, enabling devices to communicate and exchange data across local and global networks. Understanding the structure, types, and functions of IP addresses is essential for anyone involved in network management, cybersecurity, or just general internet use. And as the internet continues to grow and evolve, the transition from IP version 4 to IP version 6, this will play a crucial role in accommodating the increasing number of connected devices and ensuring the continued scalability and efficiency of the internet. And by staying informed about IP addressing practices and implementing robust security measures, individuals and organizations can enhance their network performance, protect their data, and contribute to a more secure digital environment. So whether you are configuring a home network, managing an enterprise infrastructure, or simply browsing the web, a solid understanding of IP addresses, all of this will empower you to navigate the complexities of modern networking with confidence and expertise. And by leveraging the power of IP addresses, we can ensure seamless communication, efficient data routing, and robust security in the interconnected world of today and tomorrow.